Hello YouTube, I Fix It All here, Team I Fix It All. I guess this is part 4 of Ford Distributor TFI EEC4 ignition modules and profile ignition pickup systems. Next thing on my list is something called TFI ignition module thin pins. Thin pins. Alright, so be cautious of some of these ignition modules where these pins, which is D1, D2, and D3, D1, 2, 3, are thin. I have not seen this yet, but they are substantially skinnier than what you would expect. These are the same. I'm thumbing through mine right now to see what I have. Let's see if I have an example of a thin pin. That's thick pin. That one's thick. These are thick. Yeah, these are thick. And why it makes a difference is because the profile ignition pickup, I'm calling Hall effect assembly, and profile ignition pickup is synonymous. They're the same. The terminals up in here are designed to receive a terminal that is thick enough to occupy it and snap in properly. And if they're skinnier, they're not going to mate up in here properly. Engine coolant temperature sensor. Let's say sensor versus sender. A sensor senses things and reports that to the computer. A sender reacts to something and gives the information to you on your dashboard in the form of a display, like a gauge, like a fuel needle, fuel level sender. Senders send you information. Sensors sense things and deliver it to the computer. One item in a Ford 302, and I really wished I would have dug in the manuals to show this theory of operation correctly, but in the shop manual it says if your engine coolant temperature sender is reacting in such a way to where its internal resistance is of a certain value, the computer will not let the car start. You might have momentary spark, but it goes away because the ECT, the engine coolant temperature sensor, is reading a resistance value that's low. The way those work, I think they start off at like 50,000 ohms on a bone cold engine, and as the engine gets warmer and warmer, the resistance comes down. But in an overheating condition, this sensor can help you not tear up your engine by preventing spark. Well, problem is, what if the ECT itself is malfunctioning? That's a whole different rabbit hole, but it plays into engine cranking or engine starting. And if your engine is cold and this ECT is reading low resistance, the computer is going to jump in there and prevent fuel delivery, pulse width modulation to the fuel injectors to give you fuel and what have you. It'll be hard starting because it thinks you're in an overheating condition. We already talked about the distributor gear getting stuck. That's going to the distributor getting stuck in your engine is not a good thing. I want to get into that for a second, so let's talk about that. Hang on. Let me see. Be careful on aftermarket distributors. Remember when we talked about the roll pin is drilled, but not in the center. It's offset a little bit. But also, what would happen if this roll pin hole was drilled 50 thousandths lower? Lower down this shaft. Need my pointer again. Let's say this roll pin here was drilled just a little ways lower. Well, that would orientate the entire gear a little bit lower. Well, my son had a situation where he got an aftermarket distributor, and this is what we suspect happened. The reason why is when we pulled the distributor out, the engine block was ground. There's like an ear in the cast iron block where the distributor drops into, and below that is your oil pump and your oil pump shaft. But the distributor gear was physically rubbing against this rest point on the engine block and grinding away the bottom of this gear. And the distributor was hard to get out, number one, and number two, that entire ledge on the bottom of this gear, if we can see this, it's almost like a step. All that was gone. This whole step was machined away. And by eye, you may not have been able to see that, but when you set the distributor down into the engine, you should always be careful to notice, is this flange of the distributor completely flush to your mating surface? Because he's thinking, he seems to believe that there was a little bit of a gap there, but he kind of ignored it. But that's quite a lot of damage to that gear right there. And the only way that could have happened, because we laid these distributors side by side, I had trouble trying to figure out what was going on myself. I think that what I ended up determining was this roll pin hole was drilled a little too far downward, which orientated this gear downward another 50 thou, and the engine block wasn't able to tolerate that overtaking of that space, and then that caused his gear to wear prematurely out on the bottom. And it also ate up some of his engine block, which means the next time he runs into a distributor like this, his engine block's been machined to accept a bad distributor next time. That's the good part, because that's a big ass hunk of metal that this is dropping through anyway. But it'll put that distributor up in a bind, and it'll cause all kinds of other flaky problems. Octane rod. I've always wanted to know what was up with the Octane rod. This is an Octane rod right here. And notice without the Octane rod, this here thing can just, this PIP can just move around anywhere willy-nilly, you know? So you need it to orient the location of your sensor. There we go. Because now it can't move. And the stator can spin around, and number one cylinder can be detected. Well, this is an Octane rod stamped with a 0 on it. And there's other Octane rods out there that are stamped with different numbers on it. But I was reading up on what the hell is the Octane rod and what do I need to know. And one older Ford mechanic had commented on some Mustang forum, I believe it was. He said that during the days of CAFE, California emissions and so on and so forth, and then more about automobile warranties and such, that a lot of the Ford technicians were not authorized to touch the engine timing. The only way they were allowed to make any minor adjustments to engine timing was by way of the Octane rod. So I don't know how they adjusted the rod unless there's a screw that holds it in right here. What did they do? Did they take the screw out, back it up a little bit, put a shim right here, and tighten it down? I don't know. Or swap out Octane rods with different lengths. But that's what he said. Otherwise, this reminds me of a leftover from vacuum advance days, where there would be a vacuum diaphragm here, and it would suck on the a mechanical device to pull the points one way pull the points one way or another to advance timing. That's it for that. That was part 4, I think. All right, see ya.